Buoyancy. What is buoyancy? Buoyancy is the ability to be suspended by a medium, such as a liquid or gas.
Buoyant forces are forces due to a medium's resistance to a change in pressure. Buoyant forces, shown by F sub b, are always pointed in the upward direction. This leads us into our first principle of the day, Pascal's law.
Pascal's law states that liquid that is displaced will always attempt to evenly distribute its pressure. Because of this, the introduction of any solid will create an imbalance in pressure at varying depths, causing an upward force on the object. As shown in the diagram, when the object is entered, the highest pressure is focused on the part of the object that is submerged deeper. This is how buoyant force is created.
As I lay in the pool, gravity exerts a downward force on me. In order to counter this change in pressure, the water exerts a buoyant force that is equal and opposite to that of gravity, pointing upwards.
This concept of pressure lays the way for a principle established by an ancient Greek philosopher, Archimedes. Archimedes' principle states that any object suspended by a medium has a buoyant force equal to the weight of displaced medium. This relationship can be represented by the equation F sub b is equal to the density of the medium multiplied by the volume of the displaced medium multiplied by the gravitational constant.
Let's say you have an experiment where an object is attached to a spring scale. The spring scale reads 7 newtons. That object is then placed into a beaker filled with liquid. As the object is submerged, the reading on the spring scale is reduced until it settles at 4 newtons. As the object is submerged, the water spills out of the beaker into a nearby container. If that container is then measured, you will find that it has a gravitational force of 3 newtons, which is equal to the change in newtons of the solid. This demonstrates how Archimedes' principle functions and the relationship between buoyant and gravitational forces.
The last component of buoyancy is density, which also affects how objects will react when placed in mediums. Using the equation for Archimedes' principle, you can derive an expression to show that the relationship between buoyant force and gravity is equal to the relation between the density of the fluid and the object. This new expression shows how density affects the buoyancy of an object. If the density of the object is greater than the density of the medium, the object will sink. If the density of the object is less than the medium, the object will rise. This object will continue to sink or rise until the density of the medium is equal to the density of the object. When this is achieved, the ratio of the densities will be 1, meaning that the buoyant force and gravitational force are equal, making the object stationary.
Putting these concepts together, we see that buoyancy has a host of real-world applications, as seen in submarines, balloons, boats, and planes.
For example, imagine a submarine floating on the surface of the water, only slightly submerged. To avoid detection, the submarine will descend into the water till it is fully submerged beneath the waves. Take a moment to consider at which point, on the top of the water, or submerged, is the submarine experiencing a larger buoyant force. If you said that the buoyant force would be larger while the submarine is submerged, you would be correct. This change in buoyant force is due to two changes that are experienced by the sub sinking. First, in accordance with Archimedes' principle, as the sub submerged, it displaced more water than when it was on the surface of the water, since the total volume of the submarine is now below the surface. Additionally, since submarines take on water when they descend, the gravitational force of the submarine increased. Therefore, the buoyant force must also increase for the submarine to be in equilibrium.
Imagine, if you can, a balloon attached to a weight suspended in a beaker of water with the top of the balloon being at the surface of the water. A force is exerted on the top of the balloon until it is deeper into the water than before. Once the force is removed, what happens to the balloon? Does it sink, stay where it is, or rise? If you said that the balloon will remain where it is, you are correct. As discussed earlier, when an object is inserted into a liquid, it experiences pressure in accordance to Pascal's law. Additionally, as the object is submerged farther, the pressure on the object increases. Using the gas law, as the pressure of the balloon increases, its volume decreases. This will result in the balloon maintaining its equilibrium even as it increases in depth.
In conclusion, buoyancy is the natural force applied to all solids that are either partially or fully submerged in a medium. This is explained by a combination of Pascal's law and Archimedes' principle, both of which deal with the distributions of pressure through a liquid, and the subsequent increase in pressure applied to the lower end of the solid. Buoyancy is applied heavily to submarines, balloons, and boats, and is what allows heavy objects to float on top of a medium.